Hey guys, I am here with our last lesson of the entire year. It's a little bit early. It's only the beginning of May, but we are going to wrap things up this week. So hang in there. I'm going to teach you the last thing you need to know today. So yesterday, Mrs. Voss showed you the two different kinds of probability that you need to learn this week. And the first one is independent probability. And there are some key words that go with that. And you can always pull up the notes from yesterday's video if you need to help you while you're practicing today. But independent is when you draw something out and you put it back. Or if two things are completely not related to each other. So if I spin a spinner and I roll a number cube, those two things aren't related to each other, so they're independent. Then the other kind is dependent probability, and that is when you have something like a set of marbles or a set of cards and you take one out and you don't put it back. So that changes the number of items. So for example, let me go grab something. Okay, so if I have these 4 Legos and I want to know what's the probability of getting a purple one, and then I don't put it back, and I want to know what the chance is of getting a purple one again, that's dependent because the probability has changed. So the first time when I was looking at these, I had a 2 in 4 chance of getting a purple. But then after I took one out, now I only have a 1 in 3 chance of getting purple. So that's how you can tell if something is dependent, and that's what we're going to practice today. So let's do some math. All right. Example number 1 over here says Marcus will pick a number from the hat shown below without looking, replace the card, and then choose again. So we've already seen our key word. He's going to replace the card. So if he takes one out and then he puts it back, that means that it's independent probability. Okay, now let's figure out what the two things are that he's trying to do. So what is the probability that Marcus will pick a card with the number 3 on it and then pick a card with the number 4 on it? So since we're doing two separate things here, that means that we're going to need 2 fractions. And this is where multiplying fractions comes in handy. So we're going to find the probability of finding a 3, and then we're going to multiply that by the probability of finding a 4. Okay? So the first part is going to be the same as everything that we did last week. Looking at these cards right here, what's the probability that Marcus is going to get a card with the number 3 on it? Well, we have 1, 2, 3, 4 cards that have the number 3 on it. So it's going to be 4 out of the total number of cards. So in total, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be out of 10. All right, now let's stop and make sure that that makes sense first. We won't have to take so much time with all the examples, but let's really make sure that we understand this one. So what is the probability that Marcus will pick a card with the number 3? So do it just like you did last week. The chance of getting a 3 is 4 out of 10. Okay, then he's going to put that back. So there are still 10 cards in the hat when he goes to reach in for the second time. This time we want to know what's the chance that he's going to get a card with a 4 on it. And there's just one card with a 4, so his chance of getting a 4 is 1 out of 10. Now we're going to come over here to Desmos and we're going to multiply those fractions. So we're going to multiply the numerators first and then the denominators on a separate line. So we're going to do 4 times 1 and 10 times 10. So the chance of this happening is 4 over 100. You can see that like down there, it basically sets up the fraction for you. 4 on one line, 100 on the next line. But we shouldn't stop there. We should always see if our answer can be simplified. So let's use our method for simplifying. And we'll just start with the numerator, start with 4 and see if that works. And we got very lucky this time. It does work. So my final answer is 1/25. And you won't have to simplify every time. The only part of this that's really tricky is reading the problem and then setting it up correctly. The multiplying and the simplifying, you'll get a hang of that if you haven't already. Okay, let's try the next example. Oop, I can't see my arrows. There we go. All right, example 2 says, after school, you decide to buy the candy canes in the picture below. What is the probability of randomly selecting a candy cane that is not blue, putting it back, and then selecting the green candy cane? So since I'm putting it back, this is another example of independent probability. And the two things that I'm looking for here are not blue and then green. So let's set up our two fractions. Fraction times fraction. Okay, first time you reach into these candy canes, the chance of getting one that's not blue, there are 6 candy canes total. It tells us right here in the picture, or you can count them if you want to. And there are 1, 2, 3, 4, 5 that are not blue. So the chance of getting a candy cane that's not blue is 5 out of 6. Then you put it back. So the second time you reach into this container of candy canes, there are still 6 candy canes in there. And it wants to know what's the chance of getting a green one. Well, there's 1 green candy cane, so it's 1 out of 6. Now let's use Desmos to help us multiply. 6 times 6, and I get 5/36. And then just to be careful, we're going to see if this can be simplified. Start with the numerator. That doesn't work because there's a decimal. Try 4, 3, 2, none of those work. So that means that they can really only be divided by 1, and my answer is 5/36. All right, let's try something a little bit different. All right, Alexis has a deck of cards labeled as follows. 3 of the cards have a heart, 2 of the cards have a circle, 1 of the cards has a flower, and 1 has a ball, like a bouncy ball. Okay, let's go ahead and add those up because I know that I'm going to need the total. So 3 plus 2 is 5, 6, 7. There are 7 cards total. I want to know what is the probability that Alexis will randomly reach into wherever she's keeping these cards. She will pull one out that has a circle on it, not replace it. So she's going to like throw it away or something, and then get a card that has a heart on it. All right, so let's set this up. Fraction times fraction and see what it equals. So first things first, start like normal. Don't get overwhelmed. Start from the beginning. What's the probability that she will get a card with a circle? Well, there are 2 circles and there are 7 cards. So that's it. The first part is just normal probability. Easy peasy. Okay. Then she takes that circle and it's gone. So that means that there are no longer 7 cards for her to choose from. If she took one of those out, now there are only 6 cards. So the denominator on the next part is going to be 6. And how many of them have a heart? That hasn't changed, so it's 3. And now if you can get that far, the rest is easy. 2 times 3, 7 times 6, you get 6/42. And then we come back over here and we try simplifying. Start with 6. What do you know? It worked. So that means my final answer is 1/7. Now, a huge tip here, and we're going to do this on the next one, is that when you are really confused about this, or if it seems hard, then sometimes drawing a picture will help you. So let's do that on the next example and see if it makes it any easier to understand. Okay, so on this one, we've got Angela and she's got some animal crackers. there are 3 bears, 4 tigers, 1 elephant, and 2 lions. So I don't want to draw all those animals. So what I'm going to do is I'm just going to make some dots to represent the different animals. So I'm going to say that those 3 are bears, and these 4 are tigers, and this one is an elephant, and these 2 are lions. So that when we're going through this problem, we can kind of imagine this better. In fact, while we're there, let's go ahead and count how many we've got. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. I've got 10 animals total. Now let's read the question. Let's figure out what's going on here. What is the probability of Angela selecting a bear, not replacing it, and then selecting an elephant? And I didn't talk about this in the last problem, and I should have. But if you're not replacing it, that means that it's dependent, okay? And that's when we can tell that our denominator is going to change. So let's set it up and let's look. One fraction times another fraction will give us our answer. All right, first part, the easy part. What is the probability Angela will select a bear? So there are 3 bears and 10 total animal crackers. Done with the first part. Don't let it confuse you. Now let's move on. After she draws the bear, she's not replacing it. So that means she ate it, or she dropped it, or she threw it in the trash, or she gave it to a friend, but she's not putting it back. So this bear right here is gone. Okay, so now I don't have 10 animal crackers. Now I only have 9 animal crackers. So when it says, what's the chance of getting an elephant? I have 1 elephant out of 9 animal crackers. Okay, let's come over here and let's multiply some stuff. We get 3 over 90. Let's try simplifying that. Try 3 first. And it works. Awesome. So the chance of this happening is 1 out of 30. A very small chance that this exact scenario would ever happen. Okay, I know that sometimes this can get tricky. So if you get stuck on this probability, you're going to have to reach out to us. Text us, call us, email us, video chat with us, and we can help you through this. If you get stuck on any of the problems today, tomorrow, even on Thursday, draw a picture and hopefully it will help you. Because if you talk to one of us, that's probably what we're going to be doing too, is drawing a picture. Okay, we love you. We miss you. We made it through our last lesson. Now go do those activities.